So we have our for every statement from the slope of the line that for every 2.6 grams, there are 1 milliliter or 1.0 milliliter. So that's our for every statement, again, going from the slope of the line. So how we're going to solve this first one is we're going to use our for every statement. For every 2.6 grams, there is 1 milliliter. Then I'm going to say the volume is 20 milliliters. And so when the volume is 20 milliliters, so I line that up with the milliliters. And to go from 1 to 20, I'm going to have to, this one's pretty straightforward, I'm going to multiply by 20. So to be parallel or to be consistent, I'm going to take 2.6 and I have to multiply that by 20. And when I multiply 2.6 by 20, I'm going to get 52 grams. So my solution for this first one is going to be 52 grams. So again, I'm taking and I'm using my for every statement to do this. Next problem, I'm going to do the exact same starting point. I write my for every statement. So for every 2.6 grams, there is 1 milliliter. And so for volume, I line up milliliters with milliliters. So I line up 25 milliliters here. So to go from 1 to 25, I'm going to multiply by 25. So when I multiply that by 25, to be the same, I'm going to have to multiply here by 25. So if I, in my calculator, 2.6 times 25 is going to give me a 65 grams. And so my answer for the second one is going to be 65 grams. For the third one now, it says, using that for every statement, so for every 2.6 grams, there is 1 milliliter. Okay, and now it says, predict the volume when the mass is 500 grams. So the mass is 500 grams, so 500 grams lines up here, so 500 grams. So to go from 2.6 to 500, it's not quite as easy as the other ones were. So what I have to do is I would probably need to just do this where 500 divide by 2.6, okay, that's going to give me 192. So I did 500 divided by 2.6, and that gave me 192. And so now, if I take 2.6 times 192, I should get my 500. So I'm going to come over here now, and I'm going to say my 1 has to be multiplied by 192, which is going to give me 192 milliliters. So my answer for this third one is 192 milliliters. So that's how I would go about solving this third one. For the fourth one, again, I'm going to start with my for every statement. For every statement, for every 2.6 grams, there is 1 milliliter. Okay, so 15 grams. So the mass is 15 grams. So to go from 2.6 to 15, okay, I'm going to take 15 divided by 2.6, and I'm going to get 5.8. So to go from here to here, I multiply by 5.8. So now I take that same process and I come over here and I multiply by 5.8, and I get 5.8 milliliters. So my answer for that next one is 5.8 milliliters. Lastly, it says, cite evidence from the table and provide reasoning as to why your answer for the above question 4 is reasonable. So what I'm going to do is I'm going to say for 15, so for my answer here, 15 grams is between 13.5 grams and 16.2 grams. Okay, that's from the table. If I look at the data on the table, so 15 falls between those numbers. So this answer here, this 5.8 should fall between the answers on there. And as I look, the answers that correlate or match up here is there's 5.2 milliliters and 6 milliliters. So this matches with here and this matches with here. And I have, again, my 5.8 milliliters is between these two. So my evidence supports it. My reasoning would be simply that because it matches, because what I calculated, it falls within the range of the data, it's a reasonable solution that I have. So that's how you could solve these problems using a for every statement.